All right, this is for computer science, AS level 9618, starting topic 6.1, security. So let's take a look at the learning targets, a huge list here. Explain the difference between the terms security, privacy, and integrity, dealing with data. Show appreciation of the need for both the security of data and the security of the computer system. Security measures designed to protect a standalone PC to a network of computers. Understanding threats to the computer and data security posed by networks in the internet. Describe methods that can be used to restrict the risk posed by threats. Describe security methods designed to protect the security of data. And then they want us to talk about user counts, passwords, authentication techniques such as digital signatures, firewall, antivirus software, anti-spyware, encryption, malware, virus, spyware, hackers, phishing, farming, encryption, access rights. So we'll be diving deeper into those in class, but let's go ahead and get some background so when we dive into class this will make a little more sense. So data security, privacy, and integrity, one of the first things they want us to differentiate. So data security is a requirement for data to be recoverable if the data is lost or corrupted. It's not just about it being secure. Privacy is a requirement for data to be available to only authorized users, and it can be applied to a person or an organization. When we talk about the term data integrity, it's a requirement for data to be accurate and up to date. So make sure you know the difference between all of those. Let's go ahead and move on. So security of data and security of a computer system. Data is considered secure if it's available for use when it is needed. The data is also the same as it was when it was stored. It has not been altered in any way. The security of data has been breached if the data has been lost or corrupted. Data security is a prerequisite for ensuring data integrity and data privacy. However, just data security cannot guarantee either of them. Now, a requirement to protect data is the security of the system that's used to store the data. But system security is not all about just protecting the data, though. System security is about ensuring system functionality. The second is to make sure that only authorized users can access that system. Now, there can be threats to the security system, and they can be broken down into 4 categories. The first one is internal mismanagement, and we'll talk about all of these. Natural disasters, these would be like your earthquakes, hurricanes, floods, unauthorized intrusion into the system by an individual, or malicious software entering the system. Now, measures are needed to ensure that the system remains functional whatever events occur, or if there has to be a system shutdown, at the very least to guarantee resuming of service within a very short amount of time. Now, these measures fall under what is called disaster recovery contingency planning. So let's talk about what that means. So the contingency plan should be based on a risk assessment. The plan will have a backup plan for an alternative system to be brought into action if needed. Now, if the organization has a full system ready to place the one in operation, we call that a hot site. It is ready to go. This full system ready to replace the operational one has to be away from the original system to allow recovery from natural disasters such as an earthquake or flood. If the system's nearby, it's not going to work either. If we have an earthquake or a flood in a localized area and I have my organization ready to replace a full functioning system that I have, which would be the hot site, and it's nearby, it's going to be affected by the same natural disasters as well. Now, when you're updating the system, there is a special case of vulnerability that comes into play. In the past, organizations could test and update a new system on the weekend when no service was being provided. But today, we have globally available systems. That's just normal today. There are companies that never close. Organizations may need to have the original system and its replacement running at the same time for a period to ensure the continuation of service while updating the hardware or software. Now, getting into authentication and various users. Even if a PC is used by just one person, there really should be a user account set up. And most operating systems today actually require this. Now, user accounts are essential for a multi-user system. This is what we have here at school. When you come in, you grab the computer, you log on, you have to type in your username and password. We call that system a time-sharing system. Authentication of the user is the main security feature of a user account. Now, the normal method is to associate a password with each account. Now, for this to be effective, the password needs a large number of characters, including a variety of those provided in the ASCII code scheme. All right, so there are alternative methods of authentication, and we'll be taking a look at what Google does in video when you come to class, but there are some things you can do besides passwords. Biometrics, security tokens. Now, biometric are your fingerprint, face recognition, iris recognition. If you have a phone, you may use face recognition. If you have a newer computer, you may use your fingerprint to log on to the system. Those are biometrics. Now, a security token is a small item of hardware provided for each individual user that confirms their identity. It says they are who they are. Similar protection can be provided by software, with the user required to provide further input after their password has been entered. Just having the password isn't enough. Now, it is normal and common practice to provide one of these alternative methods with the password system. It's not something that is far-fetched and out there or rarely happens. Happens all the time. General good practice that helps keep a PC safe includes not leaving the computer switched on when unattended. If you're out there in a public site at a restaurant that offers free Wi-Fi, you just don't want to leave your computer unattended, walk off to pick up your items or run to the restroom. I think most people would, not leave their items unattended. Don't allow someone to observe you accessing the computer and not writing down details of how you access it. You definitely, an ounce of prevention is worth more than a pound of cure. But it's not only about logging in. One potential problem is from users attaching a USB drive, the flash memory, which contain a virus. The safest practice is for an organization to have a policy banning these devices. Now, you might be saying, nobody is going to come up to my computer and insert a flash drive. That's not what we're talking about here. What we're talking about is users coming to work with a USB drive, putting it in there. They downloaded a file over the weekend and it contains a virus. That's what we're talking about. They're inadvertently, adding a virus to the system. Now, this is impossible, though, if a company's normal business requires portability of data. The threat that is unavoidable arises because of the connection of an organization's systems to the internet. Transmissions into the system from the internet can contain malicious software, which we call malware. Also, sensitive data from the system might be exported out to some other system. The best way to prevent these problems is to install a firewall. So let's dive in and talk about what a firewall is. So an ideal firewall will be a hardware device that acts like a security gate at an international airport. Nothing can come through without being inspected. Now, a firewall can also alternatively be offered as software. The transmission must enter the system, but it can be inspected immediately. So we're allowing the entering of data, but it's being inspected right away. So that's the difference between hardware. Hardware keeps it out, can't come in until it's inspected. Software, we allow it to come in, but it gets inspected right away. Now, the action carried out by the firewall might be to concentrate just on the address identified in any transmission, such as where is the data coming from. A firewall might examine the data within the transmission to check for anything inappropriate. For example, in an email, there can be a concern about authenticating the identity of a sender. The solution is to insist on the sender attaching a digital certificate to the email. This encrypts the email, allowing only the intended user to read it. All right, security measures, because programs are constantly running. Security measures restricting access to a system do not guarantee success and removing all the threats. There's lots of things you can do, but it's not always going to guarantee success. In addition, you need programs running on a system to check for all the problems that you may run into. Now, an option for this is a virus checker that regularly scans systems to detect any viruses and then remove them. Another is an intrusion detection system that will take as input an audit record of system use, and they start to look for anomalies in the use of logins. Now, individuals intent on causing damage to systems are using methods that are becoming more sophisticated. The defense methods have to continually be improved to counter these threats as they become more sophisticated. All right, so recovering from data loss. So we've lost data, what do we do? There are a variety of reasons for data loss, including a disk or tape gets corrupted, the disk or tape gets destroyed, the system crashes, the file is erased or overwritten by mistake, the location of the file is forgotten, we don't know where things are. A system needs a backup procedure to be in place. Now, the system administrator has to decide what the details of that procedure are. The principles for the procedure, they're pretty straightforward. A full backup is made at regular intervals, maybe perhaps weekly. At least 2 generations of full backup are kept in storage. Incremental backups are made on a daily basis. So throughout the day, we're making backups. And the backup disk or tapes are stored away from the system in a fireproof and floodproof location, and this will maximize the security of the data. So that is some ways that you can help recover from data loss, is by preventing it from happening in the first place by making backups. All right, let's continue. Now, with systems often running 24/7 these days, data can be changing all the time, and it is changing all the time. We live in a world where data is constantly changing every, multiple hours a day. Now, a simple approach to back up the data can leave data in an inconsistent state. One way to fix this is to have a backup program that freezes the file, store while the data is being copied. Now, at the same time, though, data is recorded elsewhere within the system, changes that are happening while the system is being used. So they're taking a two-pronged approach here. Now, this allows changing to the system files when the backup copy has been stored. Another solution is to use what's called a disk mirroring strategy. Data is simultaneously stored on 2 disk systems during the normal operation of the system. The individual disk systems might be at different locations as part of that disaster recovery plan we talked about earlier. All right, one more slide and we'll be calling it. So restricting access to data, which is probably the best thing you can do. If a user successfully logins to a system that have access to the system, but maybe they don't have access to all of it. The system administrator may have different categories of users with different needs with the data they're allowed to see. Does this sound familiar? It should. We do it at school all the time. Now, an example in the business world is for one employee to see another employee's phone number, but not another employee's salary. The solution to fix this situation is an authorization policy which gives different access rights to different files for different individuals. When you log in at school, you have access to see everybody who has logged onto your computer. However, you don't have access or the privilege or the rights or the administrative rights to actually access and open their folders. You can see who's logged on, but you can't access their files. Now, in another case, an individual might have read and append, which means update access, but not unrestricted write access. Authorization is the definition of a user's access rights to system components. Now, we're going to close by saying data can be encrypted, so the data collected cannot be read by an unauthorized user. Encryption is a big thing. We're actually going to be making a program that will make an encrypted password and messages. We'll be doing that when you guys come to class. By making it encrypted, it makes the stealing of data a futile activity. So that's going to be it for security. If you have any comments, please post them below. If you found this video helpful, please give it a thumbs up and help our channel grow. And we'll see you guys in the next one.